Welcome engineers. In this video we create a simple ladder logic example. Here are our conditions. In these conditions we need a start push button to start the system, a stop push button to stop the system, and 6 toggle switches to operate those lights. Here are the actual question. Take total 9 lamps and total 6 switches. Look at the third line. Switch 1 turn on 3 lights L1, L2 and L3. To create this logic I am using toggle switches. At previous video, I am talking about corridor lightning logic and using SPDT switch. The link of this video is in the description, you can go and watch it. Select this network 1 and take a normally open contact for switch 1. While pressing this NO the output turns on. And giving the address. Here you can see, when I am hit the enter button, this symbol name are enter automatically. This is because already I am mentions all the symbol names in the addresses. To open symbol table, go to S7 program, double click on it and click on symbol. Here I am mentions all the symbol name and address, like that I am mention I0.7 to the start push button and I0.6 to the stop push button. And all the other addresses. So, the first condition is, when press switch 1, L1, L2 and L3 turn on. I am taking a output coil for the lights. And add Q0.0 for the first light. For the second output, select this line. Click to open branch. And add a coil. Q0.1 for the second light. Same with the third light. Click here, open a branch, add a coil, and Q0.2 for the third light. Done, so it is a parallel connection. When switch 1 will be on, L1, L2 and L3 these all 3 lights will turn on. Let's check. So first, turn on the CPU. Click on Run P and wait for turn on this green light. Change this, PLC SIM, TCP/IP, to PLC SIM, MPI. While we are download the logic PC to CPU, then we select this MPI. Turn on the switch lights are turn on, and turn off the switch lights are turn off. It is work just like a simple toggle switch. Now check next condition. At second condition, when switch 2 will be pressed, light 4, light 5, and light 6 will be turned on. For the second condition, I am taking a new network. I am just taking multiple networks, but later, I am combine all the networks in a single network. So, select the rung and take a NO and take a output coil for the light. I0.1 for the switch 2. I0.0 address defined at switch 1, so I0.1 for the second switch. Now, select the rung and open a branch and add a coil. And at last, for the third output, open branch, add coil. So here 3 lights are ready, let's give addresses. Q0.3 for light 4, Q0.4 for light 5, and Q0.5 for light 6. And also this work as same as network 1, press switch to turn on light 4, light 5, and light 6. Again I insert a new network for the next condition. Here, the fifth condition is, press switch 3, light 7, light 8, and light 9 will be turned on. Again, this third network's logic same as first and second network. Focus on it. Here I am using 8-bit of address from Q0.0 to Q0.7, total 8-bit, so I am using 1 byte of address. Now jump to the next byte, so next address will be Q1.0. Just remember this thing, as soon as possible I am making a full video on addresses. I am showing you, when I give Q0.8 address its show alert, that's mean this is not a valid address. Let's change it to valid address, Q1.0. So, 3 conditions are complete. When switch 1 will be on, light 1, light 2, and light 3 turn on. When switch 2 will be on, light 4, light 5, and light 6 turn on. And switch 3 will be on, light 7, light 8, and light 9 turn on. Now check the other conditions. When a switch 4 will be press, light 1, light 5, and light 9 will be turn off. Now think that, when we press switch 4 light 1 gets turn off, which is connect with switch 1. Light 5 gets turn off, which is connect with switch 2. And light 9 turn off, which connect with the switch 3. So now solve this, take a normally close contact and place before of the Q0.0 output. So, when switch 1 will be on, this NC contact passes the power and light 1 will be turn on. And when this NC contact will be on, that's mean, when switch 4 will be turn on, NC contact became NO contact and it cut off the power and light 1 turn off. So, I0.3 for the switch 4. Let's check this. Press the switch 1, and it's turn on the light 1, light 2, and light 3. And when I am pressing the switch 4, it's turn off the light 1. Here is it. This same thing work with the other networks. Switch 4 turn off the light 1, light 5, and light 9. So I am copying this and paste at the Q0.4 output rung. And same with Q1.0 call rung. Here the important thing is that the address should be the same. Because I0.3 address belongs to switch 4. I will run this later. Just I am remember a new thing is, when we need a extra output or input bit, then, just click on this, insert output variable, at simulator software and change this, QB0 to 1. Now jump to the next condition. So, next, we have a switch 5, when it will be turn on, the light 3, light 4, and light 8 will be turn off. And it's same with the previous condition. So light 3 are connect with the switch 1. Light 4 connect with the switch 2. And light 8 connect with the switch 3. Now, select this Q0.2 coil rung and a NC contact, which will be the switch 5. And the address will be I0.4. And I am copy this NC. And paste at Q0.3 rung, and Q0.7. And again the reminder that address should be same. Now check the next condition. So next, when press switch 6, light 2, light 6, and light 7 will be turn off. So take a NC and give address I0.5 for the switch 6. And copy the NC. And paste to the Q0.5 output rung, and Q0.1 output rung. Okay, so here, we have a start push button, while we press the total system on, and a stop push button, while we press that the system will be off. Now, to insert a new network, right-click on the network and click Insert Network. Now, select the rail, and add an NO contact, and an NC contact, and an output coil. And assign address. For more info about memory bit, check in the description. For now just remember we don't waste output address, so, we use memory bit as a virtual address. And I am latch this push button with memory address M0.0. And run, download. Monitor on. And press start push button. and its work as a physical address. So, this M0.0 at high state, and its turn on the whole system. Now, I am add a NO contact before this switch 1. And address will be M0.0. Which is control the whole system. When start push button are pressed, then switch 1, switch 2, and switch 3 are receive the power supply. It's work like a main switch. Now, combine everything in a same network. Copy this network. And, middle of M0.0, and switch 1, I'm going to add a new branch, and paste. Same with the network 3, copy, add a branch, and paste. Delete this networks and run simulator. Press the start push button. Switch 1 press, L1 L2 and L3 are on. Switch to press, L4 L5 and L6 are on. At final switch 3 are press, L7 L8 and L9 are on. When stop push button are press, these all outputs will be off. And again when we press start push button, all lights again on, because switches are at on position. Thank you for today.